forcefully engage the wire because this bending. And in the deactivation stage, which means unloading, the wire itself tries to strengthen itself like others, like adjacents. When it wants to strengthen itself, it moves the tooth with itself. It causes extrusive movement of the tooth, like this picture. We should know some terminologies when we compare between two materials of two composition of wire. When we say this material is better in strength, we should know those informations in order to compare between materials and to know which one is better. The first one is strength. Strength, it means how easily it will break on loading. When we activate the wire, when we engage the wire on the bracket, how it easily broke, or if it is strong, it cannot be break easily. And in deactivation, how much force can deliver from the bracket to the tooth. And we have stiffness. Stiffness is how flexible it is in loading and how much force can deliver when it returns to its original shape. We have range. Range is opposite of stiffness. In range, we have how far you can deflect the maintaining its elasticity on loading and how far it will remain active. When if you did orthodontic treatment on doctor, sometimes the doctors say next 2 weeks come, I will change the wire for you. This changing of the wire depends on the range of the wire. More range, it means the more active. The more long period active, it means high range, and short period active of the wire, it means low range. So if it is short period active, you should change soon. Change the wire soon because it becomes deactive. And what is resonance and formability? Resonance is the energy storage capacity of the wires in loading and area under stress strain curve up to the proportional limit. Look at this picture. Here it is resonance, and here it is proportional limit. And behind the proportional limit, we have what? We have formability of the wire. What's formability? It's amount of the permanent deformation of the wire will tolerate before it breaks. It means that in the deactivation, how it can resist before the break point. It's the break point, and it's proportional limit. From proportional limit to the break point, we have formability. How it can resist and allow deformation before the break point. Those terms are really important to compare between the types of orthodontic requirements of ideal orthodontic wires. Ideal orthodontic wires should have high strength, low stiffness, high range, high formability, should be solderable and weldable so that hooks or stops can be attached to the wire, and it should be reasonably in cost. According to their shape and arch size, I just quickly talk about them. We have round, square, rectangular, triangular. The round is mainly used in initial stages. It means when the patient comes to treatment, initial stage we are using wire, but the square and rectangular are mainly used after that for the final stages. Those are the according to their compositions. We have metal, which are stainless steel wire, cobalt, chromium, nickel, titanium, beta titanium, and we have composite, which are ceramic, acrylic, resin, polymer, and optiplex arch wires. We will go to each of them separately. We have stainless steel wires. It's the most popular used wire in orthodontic, which contain 18% of chromium and 8% of nickel. They are resistant to corrosion and they have a good mechanical property, low cost, and excellent formability. It has a good strength and good stiffness. And the second type, we have nickel titanium. In the nickel titanium, it's useful in orthodontic alignment, and it can apply light force over the large range activation and it's super elastic. And we have different type of nickel titanium according to colors. Also, we have two colored nickel titanium, which is called Marcy. And the third type, we have beta titanium, TMA. Its commercial name it is titanium molybdenum alloy. It offers a high desirable combination of strength, springiness, and formability. It's excellent choice for auxiliary strength and intermediate finishing arch wires, especially rectangular wires for late stages of edgewise treatment. We said that rectangular pipes are used in the final stages. And we have so many new materials. They are more aesthetic, but they are high cost. That's why they are not commonly used. We say that stainless steel is the most common use, but they are new materials. They are modern materials. For example, Optiflex arch wires. They are non-metallic orthodontic wires. It has high aesthetic appearance and composed of 3 layers. The outer layer is silicon dioxide, and the body or the core is silicone resin metal, while the inner layer is nylon outer. And it can be used with any bracket system, and it's very flexible. It's got unique mechanical property. And this is the picture of flex wires. It can be used with any type of brackets. We have clear polymer arch wires. They formed from clear polymer. They have better aesthetic and physical properties equal to the metal wires. It has 2 types, formable and non-formable. The formable type, which is polyphenol polymer, properties similar to the beta titanium wires and formability similar to the metal wires. The non-formable type, which is polymer resin matrix, reinforced with a glass and fiber. And this is the picture of clear polymer arch wire. Those are my references, and thank you.